Hey MDRS engineering team, this is Paul Bakken, and I just wanted to demonstrate the prototype airlock chamber monitoring system that I came up with. It's based off of an Arduino Uno, and it's running on an external 9-volt battery supply. You can hook it up with a transformer to wall current, or it can run off the USB too. In any case, I've already uploaded the sketch into the Arduino, so it's all set to go, and I will flick the power switch here, and you can see the green light. That means it's on, and these LEDs have activated. Now it is a prototype, just a bunch of wires on a breadboard, so it's a little bit sketchy looking at the moment, but the functionality is there, which is what I'm intending to demonstrate. So the way things are laid out, there's sort of a sketch up here that shows the general layout. You've got the airlock chamber, the two doors, indicator lights, and airlock cycling request buttons on the inside, in the chamber, and on the EVA side. Now what those correspond to are these LEDs here. There's red and green. Those are matched up, and they're on both sides of the external door. So these are in the chamber, these are on the outside of the building. These LEDs are also matched, and they're on the inner door. So these two would be inside the hab, and these would be on the inner door inside the airlock chamber. When they're red, it means that the pressure between the two chambers is not equal, and that you should not open the door. And if they're green, pressure is equalized and you're good to go. So the default status when it starts up shows that the airlock chamber is pressurized. So the LEDs in the chamber and on the inside of the hab are green, means that door can be opened. These are red, so that door should not be opened. Nothing in this device actually keeps the doors from being opened, but yeah, we'll get to that later. Okay, now down here, and they might be a little bit more difficult to see, but these are the three request buttons. There's the one that's for inside the hab, there's inside the airlock chamber, and there's on the EVA side. They all do the same thing. Pressing that button initiates a request to cycle the airlock from whatever its pressure it's currently at to the other type of pressure. Now these slider switches, again, a little bit hard to see, but they're standing in for the door latches themselves. And if they're pushed to the right, that means that the doors are closed. If they're pushed to the left, that means that that individual door is open. I'm hoping to introduce some additional functionality later, but for the time being, the only thing that those do is if a particular door is left open, either of them or both, the system will not allow you to cycle the airlock. It wants both doors shut before the airlock chamber gets cycled. Generally a good idea. Okay, so let's go ahead and walk through sort of a scenario where there's some people in the hab. They want to go out onto the surface of Mars. So these lights are green, airlock chamber is pressurized, it's good to go. They open that door, and bear with me a minute. Okay, so the door is open, they walk in, and they press the button in the airlock chamber to request cycling the airlock. Oh. Okay, that's the error message. It is not letting the cycle initiate because that door was left open. So they close the door again. Alright, bear with me. There we go. Okay, both doors are now closed. They press the button in the airlock chamber. Okay, so while the pressure was changing, all of the red LEDs on both sides of each of the doors flashed red, and you heard a falling tone sequence. Those flashing LEDs indicate none of the doors should be opened while the cycle is in progress. And the falling tones are just a little bit of an audible to let people know that the pressure inside the chamber will be falling down to the near vacuum of the Martian surface. You know, let's say they're in there, they're almost ready to go out. Oops, they forgot something back in the hab. They need to go back in quick. They check both doors are shut. They're in the chamber, so they press this button. Okay. Again, the flashing lights. Cycle is complete now. It shows that the outside door should not be opened because the chamber is completely pressurized. For the inside door, we're good to go. They can go in, get the stuff that they forgot. Okay, come back out. And now they're good to go outside. Okay, so like I said, there's nothing in the mechanism that actually prevents the doors from being opened, but the features that it includes so far are the request buttons for cycling in all locations, some type of sensor to indicate whether the doors are open or shut, and all that does is it just keeps the airlock from cycling if either of the doors is open. There's the audibles that give people an audible for rising pressure, dropping pressure, and the error message if they try to initiate a cycle while a door is open. And most importantly, the indicator LEDs that tell people, no matter where they are, whether or not it's okay to open a certain door. So that, in a nutshell, is the prototype system. Should add that the cycling period, you know, it's just about 5 seconds. Obviously, that's completely adjustable to the proper time of about 3 minutes or whatever. I just made it short for the purposes of testing because I didn't want to sit around and wait 3 minutes every time to see if stuff was working. But the all of the tones, those are adjustable too. The beautiful thing about an Arduino is that pretty much everything's adjustable. So this was just one example of a system that could be put together to help augment the sim at the MDRS for the airlock chamber. And I will try to post this video on YouTube or something like that so that the rest of the engineering team can take a look at it. And as always, I'd love to hear your feedback, suggestions for making it better, stuff like that. We can take that into account. I found that programming the Arduino is super easy. I was a little bit worried about it because really my only experience is a little bit of Python, but programming the Arduino is super easy, so that's a good thing. So looking ahead to an actual implementation at the MDRS, really if this system is generally okay, the only things that would need to be changed would be the hardware itself. These buttons, we'd want to have them be a lot bigger. You know, I was thinking you can get arcade game buttons for less than $1 each. You know, they're about 3 centimeters across, slightly concave. That would be a really good choice. For the door close indicators, yeah, one of those magnetic field effect or a reed switch, similar to a home security system that indicates whether the door is open or shut, would be a good choice there. Piezo buzzers, you can probably just keep that element. They're cheap and they work pretty well. I probably want to put one in each location so that people can hear what's going on no matter where they are. And I realize that that's not truly authentic for the people who are on the outside or in the airlock when there's no air pressure, because obviously the sound wouldn't propagate. I don't know. Maybe we could do something about that to slowly increase and decrease the volume as the pressure changes. In any case, and then for the LEDs, you know, they're good and cheap, easily replaceable for the actual system. I might want to go with some of the high intensity ones, but they don't need to be a whole lot bigger. So in any case, that's the system. Hope you all like it. If you have any suggestions, please let me know. Thanks, guys.